Nowadays, we are writing code so fast, relying entirely on AI to build things in seconds, and that means we are accidentally shipping massive security holes straight into production. If you're using tools like Cursor or Claude Code, you know exactly how it goes. You open your AI IDE, type out a prompt, and the AI spits out chunks of Next.js components and Supabase queries. You just hit accept, see that it works on your local machine, and you push it live. Nobody is thinking about architecture anymore.
Biggest issue right now is that AI doesn't understand your business logic or how money flows through your app. It just wants to give you working code. Because Supabase lets your front end talk directly to your database, you rely completely on row-level security to lock things down. If you don't configure this perfectly, your entire database is wide open. Let's look at a real mistake almost everyone makes when building a SaaS. Say you are building a tool where users pay a monthly subscription to generate images. The AI will create a user table and put a column called subscription status right there. It'll say premium or free. Then it creates a policy that lets the user read and write to their own row.
This feels right, and it works when you test it. But think about what you just did. Because the user has permission to update their own row, anyone with basic technical skills can open their browser dev tools, capture the network request, and change their status from free to premium. They just bypassed your paywall in 5 seconds because the AI puts sensitive operational data where the front end can edit it. To fix this, you have to separate your data. Never put subscription tiers, credits, or rate limits on a table that the user can directly modify from the client side. You need to create a separate table for that data and lock it down so only your server or backend functions can touch it.
But there is an even faster way to lose thousands of dollars overnight, and it happens because of how we handle environment variables in Next.js. When you ask your AI IDE to set up your image generation component, it needs to make an API call to a provider like OpenAI or Replicate. To make things work quickly, the AI might add your secret API key inside a file and prefix it with next_public. This is an absolute nightmare. That prefix tells Next.js to compile the key directly into the JavaScript bundle that gets sent to the browser. Anyone can open your site, view the page source, and scrape your active API key in seconds. They will take your key, plug it into their own heavy generation scripts, and use your paid quota until your credit card is completely maxed out.
Even if you don't use that prefix, the AI loves to create direct client-side fetch requests to your image generation endpoints because it is easier than managing a back-end flow. The moment a paid API key is used inside a front-end component, you have handed your wallet to the entire internet. Environment variables are only safe when they stay strictly on the server. Another place where this exact same issue pops up is inside Next.js server actions. A lot of people think that just because code runs on the server, it is automatically secure. So you ask the AI to write a server action that generates an image. The AI writes the code, but it forgets to verify who is actually making the request.
Anyone can look at the network traffic when you click a button on your site. They can find the exact identifier for that server action, copy the payload structure, and start hitting that endpoint from a simple terminal script. If your server action doesn't explicitly check the user session on every single call, an attacker can use your endpoint to generate 1 million images for free on your budget. This brings us to a massive loophole with Supabase inside Next.js route handlers and server actions. When you ask your AI IDE to bypass security rules for a legit background task, it will tell you to initialize the Supabase client using your service role key. This key is essentially a master password that completely bypasses all your security policies.
If you or the AI write code that uses this master key inside an API route, but you don't write manual backend checks to confirm the user is logged in and has an active paid account, you have created a wide open backdoor. Anyone can call that API endpoint directly, bypass your entire UI, and trigger image generations using your master permissions. You also cannot trust front-end limits. If the AI disables a button after a user generates 5 images, that is not security. Anyone can bypass a button. You must write server-side rate limiting. Every time someone hits your endpoint,
your server should check a protected table to see how many requests that user has left before running any heavy AI tasks.
And don't just stop at user-level rate limits. If a malicious actor wants to break your app, they can write a script to automatically create thousands of fake accounts. Since each new account gets 5 free generations, they can rotate through those accounts and drain your budget anyway. To stop this, you need to implement IP-based rate limiting alongside your user checks. Your backend needs to track how many total requests are coming from a single IP address within a specific time frame. If an IP address hits your generation endpoint 50 times in a minute, you need to block them automatically, regardless of how many accounts they swap between.
Another classic mistake is not setting up budget caps on the platforms you use. If you're using OpenAI, Claude, or even your cloud hosting provider, you cannot just link your credit card and leave it open. The AI won't remind you to do this. You have to go into your billing dashboards manually and set a strict monthly limit. It is much better for your app to show an error message for a few days than for you to wake up to a 5-figure bill. The takeaway here isn't to stop using Cursor or Claude Code. These tools are amazing for speed, but you cannot let the AI do the architectural thinking for you. You have to treat the AI like a fast developer who doesn't understand security, and you need to review every line of database configuration before pushing it live. If you want to see more real code breakdowns, check out my channel for more.